Hello and welcome back for lesson 5.3. There's probably going to be two parts to this lesson today because it's just a little bit longer. And right here we are in the book. So the beginning of 5.3 kind of reminds us of our six trigonometric functions and their ratios and how they're in relationship to each other. So you can see here in the picture on the left, we have our angle. And so wherever our angle is, the opposite side of that, we're going to call the opposite. The side next to it is going to be adjacent. And it's all really kind of determined also by the side opposite of the right angle. So you can see where the right angle is here in blue, where I'm circling with my mouse. And opposite of that is the hypotenuse. So opposite of the right angle is the hypotenuse. And then we have the side that's called the opposite, that is opposite of whatever angle we're referencing, okay? And then the angle next to the angle we are referencing is called the adjacent side. And like I said, here, the ratios of sine is opposite over hypotenuse. Cosecant is the reciprocal of sine, so it's the hypotenuse over the opposite. We have cosine and secant are reciprocals of each other, and tangent and cotangent are reciprocals. Then you can also see that tangent is always sine over cosine. It ends up being opposite over adjacent. So you'll notice that when I'm working out my six ratios each time, I'm always kind of doing them in this pattern for myself. Today, we're also going to base a lot of what we're doing on the Pythagorean theorem that you've probably been introduced to before in maybe a geometry class. And so the Pythagorean theorem reminder states that if we have a right triangle, that the sides, the opposite and adjacent, are going to, the square of those two sides is going to equal the square of the hypotenuse. So we're going to use that to help us find some of the other sides today. We're also going to be using the idea of cofunction identities. Noticing that, for instance, sine and cosine are cofunctions of each other. So the sine of 90 degrees minus theta, the angle, reference angle, is equal to cosine of that reference angle. And you'll kind of see that relationship in the table that I've been making in lesson 5.1 and 5.2 for myself, that I suggested that you make as well. And then I'm going to show you what I'm talking about with that, so you can see. So going back to my table here for a minute. Remember, I said I've kind of been filling in my table. So function angles and identities mean that if the angles add to 90, so let's say we have angle 30 and angle 60, pi over 6 and pi over 3, right here and right here. You can see that sine and cosine are opposites of each other. So sine at 30 is the same as cosine at 60. And cosine at 30 is the same as cosine at 60. And it's the same with tangent and cotangent are opposites of each other. And then cosecant and secant are opposites of each other as well. So you can see here and here, cotangent and tangent, here and here, you can see the same thing. The other piece that we're going to do today, and I can just show you right here in my paper, is the angles of elevation and depression. So the angle of elevation means that, let's just say this was the ground. Then angle of elevation is the angle up to, let's say, the balloon that is up in the air. An angle of depression means, let's say this is, let's say like this is a ceiling, maybe. The way you could think of it. And then the angle of depression is if you were, holding something down, you were like lowering maybe a ladder down from the ceiling or something. So it's an angle of depression. So we're going to use those two thoughts in a couple of our story problem at the end. So I'd like to start with problems number 9. Look here. Excuse me. Allergies. So problem number 9, we have this right triangle, and they always will show where the right angle is with the square. And so the side opposite the right angle is our hypotenuse. And so they gave us that side, and they gave us the side adjacent, opposite the angle. So our angle theta, the opposite of that is 12. So it happens to be that this side here that's missing is the adjacent side. So they want us to find the 6 trigonometric functions of theta. And so to do that, we need to have all 3 sides. So we know one of them already because sine is always opposite over hypotenuse, and those are the 2 sides that we've been given, 12 over 37. And so that means we know cosecant because they are just the opposite, the reciprocal. And it's asking us in the book for the exact. So you don't have to reduce these fractions, just leave them as is because they directly tell us something about the other sides, leaving them as 37 and 12 in the ratios. So let's go ahead and try to find the adjacent using the Pythagorean theorem with the right angle. So our hypotenuse is 37. And so it's a squared plus b squared equals c squared. I missed my squared. So I'm going to call this one 12 squared. So so we can kind of come up with a little formula that we can use to help us always solve for the opposite side. So we are going to take, to solve for b, we're going to take c squared and subtract a squared, and then take the square root. So if we want to solve for b, we need to get a squared to the other side. So c squared minus a squared, and then take the square root. So I'm just going to do that on my calculator here. So we're going to take the square root of c squared minus a squared. And we get 35. So b is equal to 35. So it's always helpful to draw a picture, even if they didn't give you the triangle, to draw what you know, so it helps you kind of fill in the pieces. So then cosine is adjacent over hypotenuse. So that's 35 over 37. And then secant is the reciprocal. And then tangent is always opposite over adjacent. So 12 over 35. And cotangent is the reciprocal of that. So 35 over 12. Okay. Let's look at number 11. A little bit different setup. This time we don't know the hypotenuse, but we know the 2 sides. Oh, and I keep forgetting my square on C. So let's go ahead and find our hypotenuse. So we're going to have 4 squared plus 5 squared equals c squared. So let's set up a formula that will work every time when you don't know the hypotenuse. So c is going to equal the square root in general of a squared plus b squared. So this is going to be 16 plus 25. So c is going to equal the square root of 41. 16 plus 25. So let's go ahead and do this one in our calculator. So the square root of 16 plus, oops. Let's just do it as if we were as if we didn't know the squares. So it's 6.4. And I think that's, if you do the square root of 41, that matches. So let's leave it as the raw square root of 41. Okay, so this is the square root of 41. And so sine, cosine, tangent. So sine is going to be the opposite over the hypotenuse. So 5 over the square root of 41. Now, it's important to rationalize your denominators. That means you're going to have to multiply by the square root of 41 over the square root of 41. So this becomes 5 times the square root of 41 over 41. I'm going to show you why this is. 5 over the square root of 41. To rationalize that, we need to multiply by the square root of 41 over the square root of 41. So this becomes 5 times the square root of 41 over the square root of 41 squared. So the perfect square of a square root is just the 41. So to rationalize your denominator, you're always going to have that number ends up in the denominator with the square root of that number in the numerator. Okay, so my cosecant is going to be the reciprocal of sine. So that's why I like the raw of sine, because then I don't have to worry about what I simplified. I can have just the square root of 41 over 5, because you can have a square root in the numerator. Cosine then is the adjacent over the hypotenuse. So that one is just going to be 4 over the square root of 41, which is going to be similar, 4 square root of 41 over 41. And your secant is going to be the reciprocal of that. So square root of 41 over 4. And then your tangent is just going to be 5/4, the opposite over the adjacent. So 5/4. And your cotangent is going to be the reciprocal of that, which is 4/5. So get all 3 sides, and then you can start building your 6 functions from there. So number 17, this is a little different. It doesn't give us a picture, but it just tells us that tangent of theta is 3/2. So knowing this, we know that tangent is the opposite over the adjacent. So we could just draw a little right triangle. I'm going to call that's a right triangle. This one's theta. So opposite over adjacent means that this is 3 and 2. And then we don't know C. So remember we said C is equal to the square root of A squared plus B squared. So C is the square root of 13. And remember I said, don't worry about if it's not an even square root, an integer square root, then just leave it as the square root, because it'll be irrational and that's not going to give us exact values. So sine, so that means this is the square root of 13. So sine is the opposite over the hypotenuse. And we have to rationalize that. So that's 3, the square root of 13 over 13. And that means that cosecant is square root of 13 over 3. And then cosine is the adjacent. So 2 over the square root of 13. And when we rationalize that, it's going to be 2 the square root of over 13. So secant is equal to the square root of 13 over 2. And tangent they gave us, which is 3 over 2. So that means that cotangent is 2 over 3. See, they're fun once you get the pieces. Okay, next up is number 33. And let's go back to the book and see what number 38 is. I missed a couple. I wanted to do 21 and 23. So we're looking at 21 and 23 now. 21 is the cotangent is equal to 1.5. Okay, so let's go back to my paper here. So cotangent is 1.5. And let's put that into fraction form. It's 3/2 because that tells us something, like cotangent is the reciprocal of tangent. So this is the adjacent over the opposite. So we automatically know the tangent is going to be the reciprocal of this. So that's 2/3. And so we can fill in cotangent, which they gave us is 3/2. Okay. And we can go up and draw our right triangle. So we know the opposite is 2 and the adjacent is 3. And so we need to find C. And that's funny because the one I just chose was the tangent of 3/2. So it's basically the same thing. So didn't even notice that. So sine is going to be opposite over hypotenuse. So it's going to be similar to what we just had, but not quite the same. 2 square root of 13 over 13. So cosecant is going to be square root of 13 over 2. And cosine is going to be 3 over the square root of 13. And when we rationalize that, it's going to be 3 square root of 13 over 13. And so secant is going to be square root of 13 over 3. Okay. Let's do one that we haven't done. Okay. Cosecant of beta is 2, and I put it as 2 over 1 because they're all a ratio, and that kind of helps us find our pieces here. Let's draw our right angle, our right triangle with our theta. So let's think about this. Cosecant is the reciprocal of sine, right? And so let's just remind ourselves sine, which we're going to have to find, is opposite over hypotenuse. That means that cosecant is hypotenuse over opposite. So the hypotenuse must be 2 and the opposite must be 1. Because remember that sine and cosecant are reciprocals. Sine is opposite over hypotenuse. That means the cosecant is hypotenuse over opposite. So we need to find one of our sides. We need to find the adjacent, and we said to do that, we could do right here, b equals the square root of c squared minus a squared. So b equals the square root of c squared minus a squared. So b equals the square root of 2 squared minus 1 squared. 4 minus 1, so the square root of 3. Okay, so this is the square root of 3 is the adjacent. So sine is the reciprocal of cosecant, so that's 1/2. And then let's just fill in the cosecant. So we've got them all. Okay, so cosine is the adjacent over the hypotenuse. So that's going to be square root of 3 over 2. And so secant is going to be 2 over the square root of 3, but we have to rationalize it. So it's going to be 2 square root of 3 over 3. And tangent is the opposite over the adjacent. So it's going to be 1 over the square root of 3. So that's going to be square root of 3 over 3 once we rationalize it. And cotangent is just going to be the square root of 3 over 1, which is just the square root of 3. How exciting. So next up, I'd like to do 29 is, they gave us a secant of 30 degrees. So let's go to our book and check out what they're asking us to do for number 29. So 29 says, find the exact values of each of the following trigonometric functions, 30, 60, and 90. So it's a 30, 60, 90. So let's go back in our book here. They did a good job of going through. So on page 432, so we walked through the idea of finding sine and cosine of 30 and 60 degrees. And this is just if it kind of goes back through what we just said. Knowing that on the 30, 60, 90, B, the length of this big triangle, B is going to have 1/2 of A when you cut it in half and make these two 30, 60, 90 triangles. So it gives us the bigger picture here. Because if we had this isosceles triangle to start with, where you have little a on the left and little a on the right at the same length, and then we have the big length B on the bottom. So that's where all three angles are the same. Then when you cut in half that 60-degree angle, angle C up at the top, into two 30-degree angles, that cuts side B in half. The definition of a midpoint when you have a bisector of the angle. And so we know that side A is equal to A divided by 2 plus B. And so and then our hypotenuse is A itself. So to solve for B, we can take A squared and minus A over 2 squared. And then when you square that, you get A squared minus A squared over 4. And so you have 1A squared minus 1/4 A squared. So you have 3/4 A squared. So B is the square root of that. So B is always equal to A times the square root of 3 over 2. And then it says since 60 degree, the sine of 60 degrees is B over A, we have A times the square root of 3 over 2 over A, because that is the definition of the sine of 60 is going to be your opposite over adjacent, which is going to be your little b over, I'm sorry, it's the opposite over your hypotenuse. So it's going to be your little b over your A. And so that comes out to be the square root of 2. And the cosine of 60 is going to be the adjacent over the hypotenuse, which comes out to be 1/2. So these are just some little pieces that we're going to keep written down. But we have these also that, and so then because we know they're co-functions, we can go down just down below here, and we know the sine of 30 is the cosine of 60, and the cosine of 30 is the sine of 60. So it's also on our table here. So let me go back to the table that I've been making myself and encouraging you to work on. For instance, here is my pi over 6, which is the degree of 30, and here are my trigonometric functions. So we were given secant of 30. So we can go to our table at 30, and secant is 2 times the square root of 3 over 3. So that's here, 2 times the square root of 3 over 3. So we know at 30 that sine is 1/2. So that means that cosecant is 2 over 1 or 2. And we know at sine over 30 that cosine is square root of 3 over 2. And the tangent is sine over cosine, 1 over the square root of 3, or the square root of 3 over 3. And so cotangent is going to be just the square root of 3. And I think that they just really wanted this angle. We didn't have to find all 6. Let me go back and just look at that. So when you're working on these problems, I think this section is just find the exact angle of that one. So the next one I have is 33. So 33 says cosecant of 60 degrees. Just find that. Okay. So go back to my paper here. Sorry, I was looking at my head when I'm looking down with my glasses. So cosecant of 60 degrees. Cosecant again is 1 over sine of 60 degrees. And we know our paper at 60 degrees, sine is the square root of 3 over 2. And we already have this filled out in a table that cosecant at 60 degrees is 2 times the square root of 3 over 3. So cosecant of 60 degrees is 2 times the square root of 3 over 3. That's all we needed on that one. 37 and 41, we're getting a little practice with our calculator. It says, put your calculator in degree mode. So you're going to go to the mode button right here next to the second key, and then you should be in radians, but we're going to go over and hit degree and make sure that's highlighted. and then exit out of that. And then it said, find the tangent of 65 degrees. So we're going to hit our tangent button, which is 2 above your 9 tangent. And then we're going to put in 65 degrees in parentheses, and it's going to give us 2.144. 2.145, we should round that to. And then 41 says the secant of 15 degrees. Well, we don't have a button for secant, but we know that secant is 1 over cosine. Okay, so we can do 1 divided by the cosine of 15, and that should give us 1.035. Numbers 45 and 49, they find the cofunctions of these. So we said that sine of 35 should equal the cosine of 90 minus 35. So the cosine of 90 minus 35. So we should be able to put that in, cosine of 90 minus 35, and that's because we are in degree mode. So that would end up being the cosine of 55 should be 0.5736. Should be the cosine of 55. And they just want to know what that cofunction is. So cosine of 55. So secant of 47, what is the cofunction? So we said our cofunction identities here are secant is a cofunction of cosecant. So this should be, the cofunction should be cosecant of 90 degrees minus 47, which is the cosecant of 43. That's all they want to know there. Okay, so catch me back for the last half of the lesson. Take a little break and catch me back. We're going to start with problems 53, 57, and 61.